Let's go over the PWM with the STM32F4, and let's start with the introduction. So you pretty much can use all the timers to generate PWMs. We are going to focus on timer 4, which has 16 bits and it has 4 channels, so you can generate 4 PWMs at the same time. And this is what it's inside of the timer 4. So we're going to use these output channels. We're going to use the output comparator PWM or one pulse mode output. So we're going to set it up to PWM output, but we are using the output compare register to set up these ones as the PWM. You also have input channels, so you can read also or capture PWM signals. We're going to focus just on output for now. And the example that you're going to see on the code is timer 4, 16-bit counter, 4 channels. We're going to set up a frequency of 1 kHz for your period or 1 millisecond. And based on a 8.4 megahertz clock with a resolution of 120 nanoseconds. So we're going to parameterize this output compare register. It's the efficient approach to generate 4 different PWMs and relies on hardware to generate those duty cycles. Because you guys don't have an oscilloscope, we're going to dim an LED. So we're going to connect or route pin 12 to the green. Actually, the pin 12 is connected to the green LED. So we're going to use the green LED to see the light, the PWM affecting the average voltage of the LED. So let's go over the PWM example. This is the main code here. So inside of your main, we're going to parameterize the timer, parameterize that output comparator register, and then we're going to tell that we want that pin 12 to be working as an alternate function. So we want to route that pin to the timer, and then we're going to affect the duty cycle here, affecting this CC register. So inside of timer 4, you guys are familiar now with this. I'm setting up the prescaler to 10, so I have those 8.4 megahertz, and then my period is 8,399 times that, so I can get my 1 millisecond. So pretty much the same thing, you're familiar with this. And then configuring our output comparator register. So we have this structure where we tell that we want to use a PWM pin, or we want to produce a PWM. And this is not too important. This is the initial value of your duty cycle. I'm just saying that it's half of my, 25% of my period. You can leave it to 0 or any other value. And then I initialize channel number 1. So I have 4 channels, and I'm saying that it's just channel number 1 of timer 4, and I enable the timer 4 peripheral. Then we need to parameterize the GPIO pin. This is just an extra here. I'm going to actually not an extra, you need to do this so you can have so you can see the LED dimming in and out. And what I'm saying is now this pin, my pin 12, which is the LED green, is going to work as an alternated function, and I'm going to do a change in mapping and route that pin to my timer number 4 and initialize the pins. Then inside of your of the main code, we just initialize all those functions. I'm also using a C stick here with 1 millisecond, and on the while true, I'm going from 0 to the maximum value in increments of 5, and I affect that to the register, and I wait 1 millisecond. So every millisecond I give a new duty cycle to this timer 4. So I'm dimming up, and this one I invert the parameters here of the 4, and it dims it down. So let's see these in action, and I hope you guys understand what's going on here.